Hey, and welcome back to this our section slash only one lecture on DML, data manipulation language. The reason it's so short is because this stuff is pretty straightforward. Inserts, updates, and deletes, we're going to take a look at them all. In addition, we will take a look at variants on the DML table expression. That is, how can I specify a table, whether it's local in another schema, on a remote database built across various disks. There's a lot of different variants on that one, but again, it's not going to be difficult. All right, please download the resource file associated with this particular lecture. It's called mystoredata.txt. Go ahead and just open that guy in WordPad or whatever your favorite text editor is, and go ahead and log in as MyStore into developer, because we're going to start cutting and pasting some syntax and entering data into the MyStore schema. Granny's finally going to get some data. Good for her. As before, we'll start by ensuring that all the data is removed from our schema tables. So please go ahead, cut, paste, and then execute all the delete statements you find at the top of this script. Check out the difference between the last two delete commands where we're working on the customers table. The first reads delete from customers where customer ID is less than 50, whereas the second omits this where clause. Any guesses as to their difference? Of course, you're all programmers and understand simple Boolean logic. If we had 100 customers, all with sequential customers IDs starting with 1, then all the customers with a customer ID greater than 50 would have been retained with the first command, whereas with the second they'd have simply deleted everything. Let's take a closer look at the delete command's syntax and see what we can learn, because this is basically going to give us some hints as to how the update and insert commands work as well. Basically, they're all three variants on the same theme. Oh baby, looks like we've got all kinds of new stuff here going on. Well, let's take a look, starting from the top, and we'll work our way through it. Well, obviously the delete is a keyword, so no further explanation needed there. Next is an optional hint. Hints are a little beyond the scope of this course, but suffice it to say that this is a direct instruction to the optimizers how you want to realize this command. Remember, old Rick here had some goings on early on with respect to the Oracle optimizer, so this is something pretty close to my heart here. Next comes the keyword from, and then one of two options, either a DML table expression clause or an only keyword and then a DML table expression clause. Okay, what's that all about? DML table expression clause. Sounds like data manipulation language table. Somehow we're going to specify tables here. A DML table expression clause simply refers to the many differing ways you can point to a table in Oracle. So far, all of our examples have pointed to a table in the current schema. Very straightforward, you simply type in the table name. However, what if you wanted to reference a table in a different schema? Local database. Still pretty easy. The syntax is simply schema.tablename. Dot notation, you're all very comfortable with it, very used to it. What if the table resided on a remote server? You know, a box other than the one that you're currently typing on. Again, syntax is pretty straightforward. Schema.tablename at dblink. dblink here is typically going to be a TCP/IP connection and a port on the other end. Next, just a couple of quick terms you may want to research a little further, which again are a little beyond the scope of our course, so we're just going to touch them briefly. A view is a logical table based on a stored query, whereas a materialized view actually stores the results of that query. Again, our delete statement allows us to work with any of these objects or an only portion of any of these as the diagram depicts. Next syntax component is an optional table alias. Basically gives you the option of replacing an otherwise very long table name with something a lot shorter. For example, you might have schema.tablename at dblink and have 5 of them in a query. Well, that's a lot of typing. What if instead you gave these guys aliases of A, B, C, and D? Very common practice. Next syntax is the where clause. Easy stuff here. You guys are all programmers, so you understand Boolean logic, standard operators, standard hierarchies. In our little example here, customer ID less than 50, but it can get very complex, and as you might well imagine. We'll start looking at that when we get into queries. Finally, we have a returning clause where you can return a variable or collection to the calling routine. A very common practice, particularly when you're calling a routine where you expect a large number of rows to be impacted. You might put a returning clause on it to make sure the correct number of rows in fact were realized. Alright, that's our little discussion of the delete command. Pretty straightforward with our simple usage here, but as you might guess, can get pretty complex with respect to the DML table expression clause, and also be careful with that where clause. Biggest word of caution here is be careful when omitting the where clause. Common mistake made by starting out programmers. They forget to put a where clause on their delete, and they put that command against a table with 5,000, 10,000, or 1,000,000 rows. All of a sudden the performance of the entire database goes right in the tank, and somebody's got to get a call and says, please kill my delete statement because it's killing everybody else. It happens to all of us at one point or another, trust me. Alright, now that we have our database set up and our tables cleaned, it's time to start putting some data in these babies, and then we'll look at the insert and update commands. Should be great fun. Let's jump in the deep end of the pond. Alright, here are our three insert statements for the address types table. Let's take a look at the syntax. Insert into table name, comma, separated set of fields enclosed by parens, keyword values, and then a comma separated list of values enclosed by parens. Looks like we're creating three address type records here. One for home, one for work, and then another other type. Go ahead and create those records in your schema. Don't forget to execute a commit command to permanently move those records to disk. While you're at it, go ahead and insert all the country records as well. Nothing new to learn there. Alright. Word of caution on what we're going to learn next. In theory, Oracle does not require you to provide that list of fields. As such, you can just say insert into table name values and then a list of values. Oracle is going to match the first value in that list to the first field in the metadata associated with that table. This, guys, is a bad idea. What happens when you go and you update that table and add a new column or delete a column or something like that? All of a sudden this syntax doesn't work anymore. We're going to go through this next little example for the sake of those of you who are taking the certification exams. You need to know this syntax. In real practice, please never use it. It's a bad idea. Okay, just this once. Let's go ahead and populate the states provinces table without an explicit field list. Please know, I do this only for demonstration purposes, and I don't recommend you ever do this in practice. Alright, go ahead and execute those inserts and finish it off with a commit. Again, please don't do this in real life practice. Alright, that's 3 of our 12 tables populated. Let's move on to the products table and learn about how we're going to embed a quote within a string. I'm sure you've noticed so far that we delineate a string literal in Oracle via single quotes. Well, what if we want to sell Granny's strawberry jam or something like that, where we need an embedded quote? How do we go about it? Let's take a quick look. Let's take a quick look at this insert statement. Apparently one of our product names is Grandpa's Strawberry Jam. Well, the immediate issue is if we use single quotes to delineate a string constant, then how do we specify an embedded single quote? Looks like the answer is real straightforward. We just double them up. So Grandpa's Strawberry Jam gets 2 embedded quotes. let's give it a try by executing these product table inserts commands and then executing a simple select star from products. Cool. Looks like it worked perfectly. I'm glad. It's one of those, once you see it, you got it. Uh-oh. Looks like had a little typo there in the last insert statement when I tried to use the word shine. In fact, I just used sign, S-I-N-E. Okay, that was a setup because now we get to learn about the update command. Cool enough, let's take a look. Alright, let's take a look at this update command before we execute it. Update products, set product description equals shine, where product description equals sign, commit. Well, gang, that's pretty straightforward. I mean, again, we're all coders, not rocket science. You have to love the straight nature of SQL. Update table name, keyword set, comma separated list of field name, new value combinations followed by an optional where clause. Let's do another one where we update a couple of fields and include a little subquery. Update products, set quantity on hand equal quantity on hand times 1.5, comma, product width equals 5.5, where product ID equals left paren select min left paren product ID right from products right semicolon. Whoa, okay, what's it doing? The subquery is asking for that record in the products table which has the minimum product ID. Straightforward enough. In our case, that record has product ID equal to 1. Okay, next for the product record that has a product ID of 1, I want to change the quantity on hand value to quantity on hand times 1.5 and the product width to 5.5. Okay, let's run this guy and then a select star from products and see if it worked. There's our record with product ID equals 1, and sure enough our quantity on hand is now 15. But what the heck happened to our product width? It was supposed to be 5.5. Oh no. We better take a look at the table metadata and see what is going on. So we double click over here on the products table. Uh-oh. Looks like we tried to set a field with an integer data type to a value with a decimal. Yep, that was another learning experience, gang. Did it on purpose. Gosh, I enjoy this game. So please go ahead and commit before we move on. In addition, please go ahead and also execute and commit the insert statements associated with the customers table because there's really nothing new to learn there. Alrighty, up to this point we've used the insert syntax, that is insert into table name field list values field list. Now we're going to replace that values with a select statement that pairs up fields within the select to fields within the to receive field list. Pretty straightforward stuff and in fact very common. We begin by executing just the select part of our statement because this is some good stuff there too and we want to ensure we understand what we're doing. Select a number 10 literal, sysdate and customer ID from customers where first name is Rick. Alright, looks like we're getting all customers rows where the first name is Rick, and then from that record we will retrieve an integer constant of value 10, something called sysdate, and the customer ID. First guess on sysdate? Sure. It's the current date, and in this case you know I'm sitting here working at my desk the 12th of December 2016. Good enough. Now let's try it with the associated insert. The way this works is that you need to have an exact pairing between selected columns and the columns receiving the associated data. Data type is also important. In our case here, the literal 10 is going to be stored in the order ID column. Today's date is going to be stored in the ordered date field, and customer ID is going to get selected by customer ID. Let's give it a test and then see what we get with a select. Why did we get a customer ID of 1 instead of 10? Triggers, gang, triggers and sequences. Remember we went through this. Yeah, that's what we expected, just keeping you on your toes. Hey, while we're on the topic, why are my customer IDs so large? I thought we had set our sequencer to start at 1 for customers. Any guesses? Yeah, sure, you know. I've had to run these insert scripts a bunch of times to get this example working correctly. Okay, gang, the rest of this script is really just more variations on these same insert themes, so I'm going to let you do the cut, paste, and execute on those on your own without guiding you through it. By now you're perfectly able to do that. Alright, before we wrap it up and start looking at queries in our next section, let's take a quick review of DML, data manipulation language. We began our discussion with a look at the delete command. Really straightforward. Delete from table name where optional clause. Remember, don't omit that clause unless it really mean it, and you can really kill performance if you accidentally start deleting on a huge table. We then explored the DML table expression clause, which applies to all three of the DML commands: inserts, updates, and deletes. Basically what we learned was to specify a local table. You just give the table name. A local table but in a different schema, you use dot notation, schema dot table name. And to access a remote table, it's schema dot table name at DB link, where that DB link is typically realized by a TCP IP and a port on the other end, where that port is running an Oracle listener. It's pretty straightforward stuff. We also briefly discussed things like partitions, views, subpartitions, stuff like that. A little beyond the scope of this course, so we just briefly touched on it, but feel free to research it further if you're so inclined. Once we got done with our delete command, we looked at the insert command, wherein we used a list of values. Again, the syntax was real straightforward. Insert into table name, comma separated list of fields to receive the data, keyword values, and then a comma separated list of values to be inserted into those fields. They're straightforward enough. Next was the update command. Update table name, set, and then a comma separated list of field names and new values, followed by an optional where clause. Again, be careful with that where clause. We're going to be studying them in detail starting with our next section, but for now let's just tread gently there. Concluded our discussion of DML with a look at the insert statement, wherein we replaced the values list with a select statement. Straightforward enough. We haven't studied select yet, but it's one of those things where you can't do one without the other, because you can't learn both at the same time. So again, I think we did a pretty good job of covering DML. By all means, spend some time practicing. Now, with respect to starting queries in the next section, if you've been playing in the database quite a bit, you may want to just execute all three of our scripts before you start the next section to ensure everybody's starting at the same place, gets all of our sequencers reset, the whole thing, so we're all starting at the same game. Alright, that concludes DML. We'll see you in the next section when we start looking at queries in a more formal fashion, despite the fact that we've seen a little bit of them up to this point. We've been just sort of dabbling. Now we're going to jump in and study them in detail. You know my feelings on this. Go out there and have some fun today, but learn something every day.